So for a real-life application problem, we're talking about a pitcher's mound on a women's softball field. It's 43 feet from the home plate, and the distance between the bases is 60 feet. And we need to make sure that we understand that the pitcher's mound is not halfway in between home plate and second base. We want to figure out how far is the pitcher's mound from the base, from first base. So we know that the diamond is what they call it, but it's actually a rectangle, sideways rectangle. And we know rectangles have 4 right angles. So if here's home, and here's first, second, third, here's the pitcher in the middle, almost the middle, but not quite. We know that 43 feet from home plate is the pitcher's mound. So out to here is 43 feet. And we know that from home to first is 60 feet. So we need to complete our triangle. We know that each corner is a right angle, so half of a right angle is 45 degrees. So we have a triangle right here. We have 2 sides and 1 angle. We need to find the third side. So if you would like, we can pull out this diamond and label it A, B, and C. And fill it in with our information. Angle A is 45 degrees. We don't know side A. Angle B, we don't know. We know side B is 43. We don't know angle C, but we do know side C is 60. So we need to find side A using the law of cosines. A squared equals B squared. So 43 squared plus C squared, the 60 squared, minus 2 times 43 times 60 times the cosine of our given angle 45. So we can work this all out. .43 squared is 1849, 60 squared is 3600, 2 times 43 times 60 is 5160, cosine of 45, we put it to a decimal, although we could have used the unit circle, as 0.707. Work this all out, we get A squared to be 1800.88. Take the square root of both sides. We get side A to be 42.43 feet. So now that we have all 3 sides, we can use, actually that's all we wanted to do, is find how far away from the pitcher's mound is first base. We don't even need the angles of the other ones. So we have a formula called Heron's area formula, and it's derived from the law of cosines. We get the area of a triangle, ABC, where we have to know the side lengths, A, B, and C. We take the square root of x, s times s minus a, times s minus b, times s minus c. And s stands for the half perimeter of the triangle. And you get it by taking a plus b plus c and dividing it by 2. So we're going to do a real-life example of this one. A businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the 3 adjacent streets are 125, 280, and 315 feet. We want to find the area of the lot. So we have this triangle, and it's boxed in by streets. So the short side is 125 feet, medium side is 280 feet, and the longer side is 315 feet. So, to find the area, we first need to find the semi-perimeter. So S equals the side lengths added together, 125 plus 280 plus 315, and divide it all by 2. So 720 divided by 2 is 360. So S is 360. We're going to plug this into Heron's area formula, which I'm going to rewrite. It's the square root of S times S minus A times S minus B times S minus C. And notice that S is bigger than all of the 3 individual side lengths. So we plug it in. 360 times 360 minus 125 times 360 minus 280 times 360 minus 315. So do the parenthesis work first. Now multiply those numbers all together. And take the square root. And you do get a decimal, so let's round it to the nearest tenth. So the area of the triangular lot is 17,451.6 square feet.